Bismillahirrahmanirrahim. Assalamu alaikum dear students. I hope you all are fine in the best conditions of your health. So today we shall discuss about some general IUPAC rules for naming all classes of organic compounds. So before that you have studied the IUPAC nomenclature for the hydrocarbons, that included the IUPAC names for alkane, alkenes and alkynes. So today we shall study about the general rules that are applicable on all classes of organic compounds. The key concepts which we shall discuss today will be what we mean by the functional groups, what are the priority order for functional groups, and the IUPAC nomenclature for organic compounds, specifically if they have more than one functional group as well. So what's a functional group? Functional group is an atom or group of atoms that impart certain properties to an otherwise unreactive chain. So you know that alkanes are not reactive, and we say the alkanes are paraffins because they have little affinity, so they don't react. Why they don't react? Because they don't have any group that creates some difference in electronegativity, or that causes some changes in the dipole moment, or that causes generation of partial positive or partial negative charges, right? So these groups, if a group is attached to an alkane that creates some sort of difference in polarity, as a result of which the reactivity of alkane improves, so that group will be known as functional group, right? The functional group is actually an atom or group of atoms that impart certain properties, certain chemical and physical properties to an organic compound. So when we are considering the classification of organic compounds, so we classify the organic compounds either in terms of their common names, or we name them by IUPAC nomenclature, right? So why naming is important? Because naming is important to identify the specific structure of an organic compound, right? So the structure holds the key to all reactivity in all physical and chemical properties. So if we know the structure of a chemical compound, we can know how it will react and what will be its physical properties and chemical properties, right? So it's always not possible to draw structures everywhere, so we should know how to draw structures if a compound is given, and how to name a structure when the structure is given to you, right? The structure holds the key to the organic chemistry. The structures are named in different ways. So they are named by means of the common names, or they can be named by means of the IUPAC nomenclature, right? The IUPAC nomenclature is very well accepted, and it's actually the official nomenclature for naming any organic compound. So IUPAC name is valid throughout the world, while the common names has the limitation. If a common name is used here in Pakistan, the same common name will not be applicable somewhere else in the world. So in order to make the system uniform, it's important that compounds be named by means of some uniform system, and the uniform system is IUPAC nomenclature. So in IUPAC nomenclature, we classify the organic compounds on the basis of the functional group they contain. So the various functional groups we normally encounter in organic chemistry are listed here. So the organic compounds, we have classified the organic compounds into categories, so group A and group B. So group A includes the functional group which are indicated by prefix or suffix, right? So prefix is a name that comes at the start of the name, and suffix is the name that comes at the end of a name, right? For example, carboxylic acid. So here's the structure of carboxylic acid. You know the general structure and the name of carboxylic acid, and you should know the prefix and suffix that appears. So if the carboxylic acid is used as a prefix, it's used as carboxy. So whenever you see the name of carboxy as prefix, you should know that it is actually carboxylic acid. And when the carboxylic acid names end with oic acid, that's suffix, right? So carboxylic acid can appear at carboxy if it's used as a prefix, and it can appear as oic acid or carboxylic acid, for example ethanoic acid or acetic acid, right? So if the name is ending with carboxylic acid or an oic acid, then in that case this is carboxylic acid, right? Then aldehydes. So aldehydes, if they are used as prefix, we use the word of oxo or formyl, right? And if aldehyde's name is used as a suffix, it appears as al, right? For example, propanol, right? Then we have ketone. So this is the general structure of ketone. Prefix is oxo. So both ketone and aldehydes, they are represented by the prefix oxo, but their suffixes are different. So in case of ketone, the name ends with -one. Then we have alcohol. So if you are using the word of alcohol as prefix, you should know hydroxy. But if it's used as suffix, it is used in the form of -ol. Then we have amine. So if you are using amine as a prefix, that we use the word of amino, and if you are using it as a suffix, that is, it is forming the end part of the name, then we use the word of amine, right? So suffix are the part of the names that appear at the end of your name. However, if a functional group is represented at the start or in the middle of the name, then we have to use the prefixes. Now we have some functional groups that are only represented by suffix. For example, alkene. So alkene are always represented by suffix of "ene", right? So there is no prefix for alkene. Similarly, alkynes. Alkyne don't have any prefix. They are always represented by a suffix. So suffix for alkyne is "-ine", Y-N-E, right? So whenever you see a word that ending with "ene", so you know that actually the functional group is alkene, and if the name is ended with alkyne, for example benzene, right, or hexine, so whenever a name is ended with "-ine", it means that's an alkyne, right? So whenever a name has an oxo as a part of the name, that means you have an aldehyde or ketone as a part of your name. And if you have an "-ol", that means the alcohol is forming the last part of the name. And if you're using the word of hydroxy means that this group is part of the name, but that's not forming the end part of the name, right? So why, if name forms a prefix, or why a name appears as suffix, right? So the condition of using of prefix or suffix for the functional group appear in case if you have more than one functional group, right? So if you have only an alcoholic functional group in your compound, then the name will always end with "-o". But if you have more than one functional group in your compound, then the alcohol may end with hydroxy, or its name may end with "-o", right? So whether you will use the word of hydroxy or you will use the word of "-ol will depend on whether the functional group of alcohol has precedence over the other functional group or not. For example, if you have two functional groups, so which will form the suffix? The group which has higher priority will form the suffix, and the group which has lower priority will form the prefix part of the name, right? So just see here. So if you have a polyfunctional organic compound, that is, you have more than one functional group, then one of the functional group is considered as the principal functional group, right? So the principal functional group is given the preference, and its name will end as suffix. So suffix is always formed by the name of principal functional group, right? So here we have a list of various functional groups, and this is increasing priority. So you can see the carboxylic acid is at the top, right? So since it's at the top, it means it has higher preference. So its name always almost ends with oic acid, right? So since its name is ending with oic acid, so we are using the suffix, right? But if you have, suppose, an aldehyde and a ketone, so here you can see in the name that aldehyde has preference over ketone. So if you have an aldehyde as well as a ketone in a group, then the name of ketone will form as a part of prefix. So you will use the word of oxo for ketone, and the aldehyde name will end as al, right? So suffix always is used for the functional group that is considered as the principal functional group, and prefix is used as the name of the group which is not the principal functional group, right? So the principal functional group has its name at the end, so we use the prefix for principal functional group, while all other functional groups are treated as substituents. For example, if you have an amide and an aldehyde, so in the list you can see that amide has higher preference over aldehyde. So amide will form its name at the end, so amide will appear as a suffix, while aldehyde's name will form the prefix. So we will use the oxo term, or we can use the term of formyl, and in case if you are using an aldehyde as substituent, right? So this aldehyde will be considered a substituent, and this amide will be considered as principal functional group. So you must have this priority list in mind. So just have an idea. So if you just practice once or two times, you will have the idea that which group will have high preference and which will group have low preference. So now you have a compound and you have to give its name. So where to start and which rules should be applied first, right? So there are two sets of rules in IUPAC nomenclature. There are some rules that are fixed and that have to be applied on each and every structure, and there are certain rules which are not compulsory and which are applied without any sequence while writing some names, right? We shall study these rules one by one. So just for example, what we mean by certain rules we have which are fixed and certain rules which are applied without any sequence. So for example, you cannot select the longest continuous chain, right? Or you cannot start the numbering before you decide the principal functional group. So this is a fixed rule, right? So certain rules are fixed, you cannot compromise on them. So if there is only one functional group, no problem, that functional group is your principal functional group. But if there are more than one functional group, then the first rule will be you have to select the principal functional group first, then select the longest continuous chain, then start the numbering, right? So you cannot start the numbering or you cannot select the longest continuous chain unless you decide what is your principal functional group, right? So here we shall discuss some 14 essential rules which are required to write the chemical name for any organic compounds. So firstly we'll discuss about the basic rules which are fixed for all organic compounds. Rule number 1. So the first rule is that you have to identify the principal functional group, right? So if the structure contains only one functional group, then that is directly considered as the principal functional group. For example, here you can see, so here we have 4 carbon long chain. So with 4 carbon long chain, you know from IUPAC nomenclature for alkanes the name is butane, but here we have a carboxylic acid as a functional group. So since it is the only functional group, so its name will appear as suffix, right? So you have to add a suffix of oic acid, right? So the name will be butanoic acid. We have to replace the E of butane with oic acid, right? So this oic acid is appearing as a suffix. So this is the case in case if you have only one functional group, but consider if you have more than one functional group. So in situation you have to determine the priority order. So just for example, in this case you have an alcohol functional group and carboxylic acid functional group, and if you see the priority order here, so you know the carboxylic acid is on the top. You see that carboxylic acid is on the top, so its name should end with a suffix, so it should be a principal functional group. And here we have an alcohol, so alcohol has a lower preference than carboxylic acid, so you will use the prefix for this alcohol, right? So here we have the structures, and we know from the preference order that alcohol has lower preference, so it's not the functional group, it will be considered as a substituent, and this will be the main group, that will be the principal functional group, and the name should end with oic acid, right? So since we have to use the prefix for hydroxyl, so we will use the word of hydroxy, and that will end with oic acid. So we have 1, 2, 3, 4. So we have 4 carbons. 4 carbon chain is known as butane. So we have the E of the alkane removed and replaced with an oic acid. So we have butanoic acid, and we have to start numbering from the principal carbon, principal functional group. So the numbering should be 1, 2, 3, and 4. So the name of this compound will be 4-hydroxy butanoic acid. Okay, now we have the second rule. After we have selected the principal functional group, next thing is that we have to select the parent chain, right? So parent chain should be the longest continuous chain, as we know, but one thing important is that you should not ever select a chain without principal functional group. So principal functional group must be the part of your parent chain, right? Even if it's not the longest continuous chain as well. So if you have a longest continuous chain but the functional group is not present in that, you cannot select that parent chain. So we have 2 examples here. So firstly we consider this one. So we have 2 possibilities. So suppose that we select this straight chain as longest continuous chain here. Right, so it has 1, 2, 3, 4. It has 4 carbons. Right, so it has the principal functional group and it has 4 carbons. Right, so its name should be butanoic acid, and we have an ethyl at carbon 3, so we say that this is the 3-ethyl butanoic acid, but it has 4 carbons. So let's consider another possibility. Now we consider that this chain. So if we consider this chain, again we have to select the longest continuous chain with the functional group, right? So we have this principal functional group here, and if you count the carbons, so it has 5 carbons here. So this is the longest continuous chain, and it has 5 carbons with the principal functional group. So this is the correct selection for this structure. Also, we cannot select this chain. It has 4 carbons, but it's not including the principal functional group, right? So this selection will be wrong. So you have to select the longest continuous chain with principal functional group here. So you have to start the numbering for principal functional group, and we have 5 carbons, so we have the name of pentane, and since that's a carboxylic acid here, so we have to replace E of the pentane with oic acid. We have pentanoic acid, and to this 3rd carbon of pentanoic acid we have a methyl, so we'll write 3-methyl, right? See, the methyl is appearing at the first, right? So things that appear first, they are substituent, and things that appear at the last are the root name. So the name will be 3-methyl pentanoic acid, right? So here we have another example. So if you want to select the longest continuous chain here, you can see that this is longest continuous chain, right? So this continuous chain has 5 carbons, but when we are selecting this longest continuous chain, this functional group is not part of the chain, so our selection is wrong. So instead of selecting this chain, so you can select either this side, right? So you can see 1, 2, 3, 4. It has 4 number of carbons, but still it has the principal functional group, so this selection is right. Or the other way around, you may also select this side. Since the molecule is symmetrical, it doesn't matter if you select this side or that side. So when you have to name this structure, then we have, you can see 1, 2, 3, 4. So you have to start numbering from the side of principal functional group. So 1, 2, 3, 4. So this is a 4 carbon chain, so that's a butane, and since that's an aldehyde, so we have to replace the E with Al. Just see, we are not using the word of formyl, or we are not using the word of oxo, because this is our functional group. This is our principal functional group. Whenever the group is principal functional group, we have to use suffix. We should not use the prefix, right? And there we have an ethyl group attached with the 2nd carbon, so the name will be 2-ethyl butanol. Okay, the 3rd rule. So if you are selecting a parent chain and there are more than one possibility, right, what happens then? Right, you have to, as per the 2nd rule, you have to select the parent chain that should be the longest continuous chain including principal function group. But suppose that if we observe, then we have more than one possibility, then we have to see different criterions, right? So if you consider this structure, we can select this system, right? So we cannot select this chain. If you select this chain, for example, so if we select this longest continuous chain with 5 carbons, we see that one of the functional groups, principal functional group, is part of the chain, but there is another functional group which is not part of the chain, right? So in this condition, when we have one or more than one functional group, and we are selecting a chain that has only one functional group, then you must consider the possibility in which both of the functional group are part of the continuous chain, right? So this selection will be not right. So instead of this structure, we will consider this possibility in which we have both of these as part of the longest continuous chain, right? So both ways we get 5 carbons each, but in this way we get 5 carbons with both functional groups as a part of the chain, right? So numbering will be starting from the principal carbon. from the principal function group. So numbering will not start from aldehyde, that will be start from the carboxylic acid side, because carboxylic acid has higher preference over the aldehyde group, right? So you will name 1, 2, 3, 4, and 5, right? So the name, if you want to see, that will be. So we have at 3 position we have an ethyl group, and at 5 carbon we have an oxo group, right? So we'll see, we name that as 3 ethyl, 5 oxo, right? In 5th position we have an oxo group, and or we may say that's a formyl group. You may use formyl if you have confusion, or you may also use the word of oxo, right? So here we will use the word of formyl here, right? So you have 5 formyl, so 3 ethyl, 5 formyl, and that will be pentanoic acid, right? So this is the way, in case if you have 2 possibilities for selecting a parent chain and there are 2 functional groups, ensure that both of the functional groups are part of the longest continuous chain. Alright, so there are basically 2 criterions if you have to systematically study. Number 1, first criterion is that the chain containing a maximum number of functional groups must be considered, which we have discussed just right now. And second, the chain having maximum number of side chains must be selected, right? So in this criterion, in this example, we have considered that we have chosen the chain with maximum number of functional groups, and let's see this criterion, right? This is, so we have chosen this chain because it has 2 functional groups here, right? So you have to select the numbering that has 2 functional groups here. So we'll prefer the numbering in which both functional groups are as a part of chain, while the red numbering has only one principal functional group as part of the chain, so we'll not consider that numbering. So here is the second criterion. So if you have like system like that, so as such there is no functional group here, but when you are to select the longest continuous chain, which will be longest continuous chain, right? So the first thing we have in mind, okay, this is a straight chain and that is having 5 carbons here, right? So our natural choice will be that one, but this is not right. So we have to select the chain that has maximum number of side chains, right? If we select this structure, say it has only 1 side chain here at carbon number 3, but if we select this structure from here, you can see the number of carbons are still 5, but here we have 2 side chains, right? So it's 2 side chains. This have the preference of selection, right? So whenever you have confusion whether you will select this chain or that chain, so there are 2 criterions. Number 1, you must select the chain that has maximum number of functional groups, and second thing is that you must select the chain that has maximum number of side chains. So the correct name for this will be 3-ethyl to methyl pentane, right? So this is about the 3rd rule. Here we have the 4th rule, right? So the 4th rule is regarding giving the root name. Root name is actually the last part of the IUPAC name, right? So normally we use the longest continuous chain of the carbon to determine the root name. For example, if your chain has 5 carbons, then the word of pent is used to indicate the 5, right? So pent is basically the root name. For example, similarly, if you have a 6 carbon chain, so to indicate the 6 carbon, we indicate the word of hex. So hex is the root name. Root name can be modified if there is any functional group. For example, if you have a pent of pentane as a root name, and if the functional group is carboxylic acid, then the root name will be modified as pentanoic acid, right? So pentanoic acid is actually the oic acid will be the root name, right? The root name can be modified by the principal function group, and the root name is given by counting the number of carbons in the parent chain. So depending on the number of carbons, you can select the root name. For 1 carbon, the root name is meth. For methane, for 2 carbons, the root name is eth. For ethyl, for propane, we have prop. For pentane, we have pent. For hexane, we have hex, right? So depending on the number of carbons, the root name can be changed. and also the presence of functional group can modify the root name. For example, we have to consider the root name for this structure, right? So just count the number of carbons. The number of carbons in this structure is 5, right? So 5, we use the root name of pent, right? So that's all carbons are single bonds, so it was actually pentane, but we have a carboxylic acid here as a functional group, which is principal functional group. So we'll remove the E of alkane and add oic acid as a suffix. So the name will become pentanoic acid, right? The name will be pentanoic acid, right? So in this way, we can give the root name for any compound. So just count the number of carbons, consider the functional group present, right? And replace the E of the alkane with the suffix of your functional group. Then you will get the root name. So the name will be pentanoic acid. Okay, now the fifth rule is numbering, right? So far we have studied about we have to select the principal functional group, right? Then we saw that we have to select the longest continuous chain that must contain the functional group. Then we saw different criterions. If there are multiple choices available for the selection of longest continuous chain, we must select the continuous chain that has maximum number of functional groups, or we must select the chain that has maximum number of side chains. Next, we saw about how about using the root name. Right now we will study about how we are going to assign numbering, right? So the numbering is assigned in order to identify the location of the side chain or location of the substituent. So in IUPAC nomenclature, the position or location of a side chain or the substituent is known as locant. So whenever you see about this word of locant, locant means the location of any substituent or any side chain, right? So always remember that numbering should be done from the direction that gives least number to your principal functional group, right? The principal number functional group must be assigned least number. Preferentially that should be given first number, but if it's not possible to assign first number to the principal functional group, ensure that you are numbering from the side that gives least number to the principal functional group. For example, consider this structure. So we have an alcoholic group. You know that alcohol is the only functional group here, so that's the principal functional group, and since it's forming the principal functional group, the name should end with ol, right? So we will use the suffix for alcohol. So here you can start numbering from here. So if you start numbering from here, 1, 2, 3, 4, the alcohol will get the 4 number. But if you start from here, 1, 2, the alcohol is getting 2 number, right? So you should now start the numbering from the side that gives least number to the alcohol, or which gives least number to the functional group. So in this specific case, the name IUPAC name for this structure will be 2-pentanol, right? So you're seeing that we have replaced the E of the alkane with O of the alcohol, right? So this is the right name for this structure. Rule number 6. In case if there is more than one possibility for numbering, then we have 2 criterions, right? First criterion is that sum of the locant must be least. So this rule is known as least sum rule. In short or in briefly, that you must assign least number to all the substituents, right? You should number the chain in such a way that all of the substituents get the least number. And this rule can be also stated that sum of the locants should be least. This is known as least sum rule. The second criterion is that least number should be given to the side chain that comes alphabetically first. So you have an ethyl as side chain and a propyl as side chain, then you must give least number to ethyl because that comes first alphabetically. So just elaborate this with a few examples. So here we have the possibility, right? In this case, so we have, you can see that 3 substituents. So we have chloro, bromo, and chloro. So we can start numbering from 2 sides. We can start numbering from here, 1, 2, 3. So if you see that chlorine getting 3 number, bromine getting 4 number, and chlorine getting 5 number. So if you just add them all, 3 plus 4 plus 5, that gives you 12. So the sum of the locants is 12. Or from, if on the other side, if you number from here, 1, 2, 3, 4. So here chlorine's getting 2 number, bromine's getting 3 number, and chlorines are getting again 4 number. So the total of this 2 plus 3 plus 4, that's 9, right? So this is the least sum rule, that you have to assign least number to the substituents, right? Or you may say that the sum of all the locants must be lowest, right? So this is giving the lowest sum, so this side will be preferred. So we will start numbering from this side. So the name of this compound will be, right, so alphabetically the bromine comes first and chlorine comes last. So the number will be 3 bromo, 2 4 dichloro, because chlorine is appearing 2 times, and since it's 6 number chain, so hexane. So the root name is hexane, right? So in this way we can number if there is any confusion. So first rule is that, first criterion is that you must select the least number, right, for the all substituents. The second criterion is that if you have different side chains, right, in that case side chain that is alphabetically, or the substituent that comes alphabetically, will be preferred first. For example, consider this system. So if we start numbering from here 1 2 3 4 5, then chlorine is getting 2 number, bromine is getting 4 number, and if we select from this side 1 2 3 4, again one substituent as 2 position and other is at 4 position. The both of the substituent are at same position in both of the cases. So the least sum rule is same for both. One substituent has 2 position, other is at 4, so sum is 6. Similarly, sum is 6 here as well. So what is the next criterion, right? So if the least sum rule is same in both cases, the next thing is that the side chain or the substituent that comes first in the alphabetical order, that will be named first. So here we have bromine. So bromine comes first alphabetically, so you will assign first number to bromine and next number to chlorine. So numbering will be preferred from side of bromine, because bromine is coming first on the alphabetic order, right? So this is, in this way the correct name will be 2-bromo 4-chloropentane, right? So this numbering will not be preferred, because in this numbering the chlorine is second in the alphabetic order, and that's getting a lower number, right? So you have to give lower number to a substituent or to a side chain that comes first in the alphabetic order. Now we have studied about the fixed rules. We have studied about the first rule is that we have to select the principal functional group, then we have to select the principal chain. We have studied about different criterions for selecting the principal chain. Then we have studied about the giving of root name. Then we have studied about the numbering of the side chain. Now after these fixed rules we have some other rules, right? So these other rules are applicable under special conditions, and they are not applicable to all organic compounds. So first rule in this regard, or overall the rule number 7, is that if there is a substituent on any heteroatom. So what do we mean by heteroatom? The atoms other than hydrogen and carbon are considered as heteroatom, right? So common heteroatoms that are normally observed in organic compounds are nitrogen, oxygen, sulfur, and phosphorus, right? So if any of these atom is substituted, the substituent is indicated as a prefix, right? So here we have substituent on nitrogen, right? So you see that the nitrogen has 2 methyl groups, so we will not indicate any number for this. We will say NN dimethyl, right? NN dimethyl means there are 2 methyls and both are attached to this nitrogen, right? And by convention these NN are written in the form of italic, right? So this substitution on heteroatom, so if you have an oxygen with methyl, so we write O methyl or S methyl, right? So whenever there is a substituent on heteroatom, those substituents are added as prefix. So in this case the name of this functional group will be NN dimethyl 1-butane amine. You see that functional group is amine here, so the name is ending with amine. So amine is the actually suffix for amine functional group. The rule number 8 is numbering of the side chain should be starting from point of attachment, even if it bears any functional group, right? So here we have our principal functional group here. This is our principal functional group carboxylic acid, and this is our longest continuous chain here. So if you select this chain, then in that case we will have different substituent as well, but the number of carbons will be much lower, 1 2 3 4 5 here, right? There will be 5 carbons, but here we have 6 carbons. So we'll select this chain and we'll consider this chain as a side chain, right? So whenever there is a side chain attached, and to that side chain also you have further any further substituents, then the side chain is numbered in the form of prime number, right? And always start the numbering at the point of attachment. Right, so we will not start numbering from alcohol side because alcohol has preference, but we will start numbering from this direct point of attachment, right? So the numbering will of the side chain will start from the point of attachment. So we'll start numbering from here 1 prime 2 prime, right? So whenever you are seeing prime numbers, it means that is numbering of the side chain here as well. So the name for this will be, you can see the side chain is attached with 3 carbons, so 3. So at 1 prime carbon we have chloro, so 1 prime chloro, 2 prime hydroxy. Since hydroxy is appearing as a substituent here, so we are not using the word of ol, we are using the word of hydroxy. 2 prime hydroxy, and this the chain has 2 carbons, so we will use the word of ethyl, right? So the name of the side chain is 1 prime chloro, 2 prime hydroxy, ethyl, and the rest name will appear as such. Also, the side chain are named in the form of parentheses. You will use those brackets, small brackets, and whatever is inside the bracket, that is actually the side chain, right? So the name will be 3 hyphen 1 prime chloro 2 prime hydroxy, ethyl bracket close, means that's the side chain, hexanoic acid, right? So the point of attachment is 1 prime, so you must select the numbering from 1 prime and you should name like that. So the side chains are always numbering with a prime in order to differentiate it from the main chain, right? So this is actually the correct IUPAC name for this structure. Rule number 9. So in case if you have multiple substituents or multiple side chains present more than once, right, then in case if you have multiple substituents that are appearing more than once, then you have to use the prefix like di, tetra, penta. So in this specific case we have 3 chlorine that are appearing in this structure, right? So since there are 3 chlorines, so we will say trichloro. If there were 2 chlorines, we would have used the word of dichloro, right? So if the substituent or side chains are appearing more than once, then in that case we will use the prefix of di, tri, tetra, penta, etc. So in that specific case, so you can start numbering from here or you can start numbering from here, doesn't matter, because the molecule is symmetrical, so that name will be 2, 3, 4, right? The numbers should always be separated by a comma. There should be always a comma between numbers, and there should be always a dash or hyphen between number and name. So whenever you have numbers, you have to place comma. Whenever there are 2 or more substituents, you have to place comma, but there is always a hyphen between a number and a word. And between 2 different words, there is always a comma, right? So when you are dealing with numbers and numbers, place comma. When you are dealing with name and name, use comma. But whenever you have a number and a name, then always you have to use a hyphen here, right? The correct name will be 2, 3, 4 trichloro-pentane. Okay, so rule number 10, side chain with side chain. So if you are having this is our principal chain, and this principal chain has 2 side chains, but these 2 side chains are further divided, right? So you have substituent which is further substituted. In that case, right, if the same side chain is repeated, we don't use the word of di or tri, we use the word of bis, tris, tetrakis, pentakis, depending on if those side chains are appearing 2 times, 3 times, 4 times, or 5 times. So you can see here that this group, right, this is actually an isopropyl group, but if you see, this is a side chain which is further subdivided. Whenever you have side chain which is further subdivided and it appearing more than once, right, then we have to use the word of bis, since it is appearing 2 times, so that's bis. So this is bis isopropyl because isopropyl is appearing 2 times. So we will not say diisopropyl, we'll say bis isopropyl. So if there were 2 chloro, we would have used the word of dichloro. If there were 2 methyls, we would have used dimethyl. If there were 2 ethyl, we would have used diethyl. But if you have a branched substituent, and that branch substituent is appearing more than once, then you have to use the terms of bis, tris, tetrakis, pentakis, depending upon how many times that substituent or that side chain is appearing. So in this specific case, the name will be 5,5 bis isopropyl, because isopropyl is appearing 2 times, octane. Octane is the root name because it has 8 carbons here. Rule number 11, multiple groups if they are joined by a single bond, right? So for example, we have two phenyl groups, and here we have 2 situations. If these 2 groups are separated by a carbon, then we use the word of di, right? And if those 2 groups are directly attached to a sigma bond, then there's no carbon in between, then we use the term of bi, ter, quarter, etc. So this example, so since these 2 phenols are separated by a carbon, so we say diphenyl methane, because 2 phenols are attached with the methane, right? So di term is used in case if cyclic groups are attached to a carbon. So these are attached to a carbon here, so we'll use the term of di. So in this case, the name will be diphenyl methane. But in case if the 2 methyl or if the 2 benzenes are attached through a single bond and there is no carbon between the 2 benzenes, then we use biphenyl, right? So although the word is ending with il, it's not a radical, but it's a compound name, right? So whenever you have a biphenyl means that there is no carbon between 2 benzene rings and the 2 benzene rings are joined by a single bond. Rule number 12, right? So all side chains are arranged alphabetically order, prefixed by the position the carbon chain. So if you have ethyl, methyl and propyl, so ethyl comes first, so ethyl will come first in the alphabetic order, then comes the methyl, and then will come the propyl, right? So all side chains must be arranged in alphabetic order and their position must be prefixed by the locant on their parent chain. Rule number 13 is that there are certain prefixes which are included and there are certain prefixes which are not included as a part of IUPAC name, right? So we'll see about what prefixes are excluded and what prefixes are included. So whenever you have prefixes like bi, ter, tetra, di, tri, tetra or secondary or tertiary, you will not consider them as a part of IUPAC name, right? So although we have dibromo, so di is coming first, right? Although C is alphabetically first, but we will not consider this di, right? So we'll not consider this di in alphabetic order, so we'll consider only B of the bromine, right? So whenever you have prefix like bi, ter, tetra, etc., they are not considered in the alphabetic order. So you'll ignore them when you are arranging the substituent in terms of alphabetic order. However, the prefixes like cyclo, benzo, 1H, 2H, isoneo, etc., so these suffixes are used in the alphabetic order, right? So if you have a pentane, if you have a cyclopentane, then cyclopentane will appear first because C is appearing first and P is appearing in the later stages, right? The C of the cyclo will be considered in alphabetic order. But if you have a bimethyl or dimethyl, right, the di or bi will not be considered in alphabetic order. Similarly, if you have an isopropyl or a neopropyl, right, so the iso or neo terms will be considered in alphabetic order, right? So the fragment of iso will come first and the neo will come last. So these are the prefixes which are included in alphabetic order and these are the prefixes that are excluded in alphabetic order, right? For example, we have 2 bromines here, right? So we'll say these are dibromo, but di should not be considered in alphabetic order because that's listed here in the excluded alphabets. Here is the rule number 14, naming of the radical. So the radical, as you know, that if we remove a hydrogen from a hydrocarbon, then what's left behind is known as a radical, right? And radicals name end with il or some other suffix depending on how many of the hydrogens have been removed here. So this is a certain table which will helpful for you in order to decide that which suffix for the radical you will use, right? So if you have a radical from which one hydrogen has been removed, we say the radical is univalent and the suffix will end with -ile. For example, if you remove one hydrogen from ethane, then the suffix will be, the radical will be ethyl, so word will end with suffix of -ile. So if you remove two hydrogens from a hydrocarbon, then the radical is considered to be a bivalent and the name will end with yylidene. And if you have removed three hydrogens from a certain carbon, then in that case the resulting radical will be considered as trivalent and the name will end as yylidine, right? So just for example, here are examples. So here we have ethyl, so you see one hydrogen has been removed, so the name is ending with -ile. So we have removed the ane and replaced with -ile. Here we have removed two hydrogens from this carbon, so we will remove the ane and replace it with yylidene. And if we have removed three hydrogens from the carbon, then in that case the radical will be considered as yylidine, right? So this is yylidine because three hydrogens have been removed. So this is an example. So we'll consider just side chain here. The rest is the same almost. So here you can see that this fragment is an ethyl. Why is it an ethyl? Because one hydrogen has been replaced from here, right? So in that case this is an ethyl radical. But here in that case you can see this is the side chain, and from this side chain there are two hydrogens missing. So since two hydrogens have been removed, we say this is yylidene. Right, so we'll say this is ethylidene. That was ethyl, and now since there is a double bond, two hydrogens have been removed, we say this is ethylidene. Now here we have another carbon. Again you can see this is an ethane, right? Two carbons, ethane, but from this carbon we have removed three hydrogens. So since three hydrogens have been removed, we will say it as ethylidine, right? So depending on how many hydrogens have been removed, we use the terms of -ile. We use the suffixes of -ile, yylidene or yylidine, depending on how many hydrogens are removed. So if one hydrogen is removed, we say that radical is univalent and the name of the radical will end with -I. If we have removed two hydrogens, then we say radical is divalent and the name will end with yylidene. And if we have removed three hydrogens, then the name of the radical will end with yylidine and we say the radical is trivalent. And that's all about the general rules for general IUPAC rules for all organic compounds. I hope you have understood it well. Thanks all for your patience and attention.